Welcome to episode 13 of Running on OCP, where we speak with organizations using open compute in a variety of ways, including end users, software companies, and organizations who align to the OCP tenets. This week, we head to one of the most northern outposts of computer science research happening today, and that is in the north of Sweden at the Research Institute of Sweden, or RISE. Jon Summers and Tor Minde will be joining me. Jon is a research lead for data centers at RISE, as well as an adjunct professor of fluid mechanics at Luleå Technical University. Tor Minde heads up the ICE Data Center Efficiency Unit within RISE, and this unit not only focuses on efficiency and sustainability, but also runs a space data lab for the Swedish Space Agency. So Tor and Jon are great at provoking new and different ways of thinking about PUE, efficiency, and sustainability. So I always learn a lot when I speak with these two, and I hope you do too. Enjoy this week's episode of Running on OCP with Jon and Tor from RISE. So thank you, Jon and Tor, for joining me.
Yeah, thanks for inviting us.
Thanks for inviting us. Yeah, good to be here.
Yeah, it's great to have you guys. So this is the first discussion I've had with more of an R&D angle. So tell the community a little bit about yourself and how you got involved in the research. So we can start off with you, Jon, and then move over to Tor.
Yeah, I guess it goes back to my time as working in academia in the University of Leeds. I've worked with high performance computing for many years, and then got into the fact that the computing is actually a problem from the perspective of thermal management and energy management. So we ran a few research projects around that with a couple of companies and got into liquid cooling in a big way. And then RISE happened. I guess they came up on the map I had a small lab in Leeds, and then RISE said, we've got a really big lab over here. So naturally, that's where I should go. Bigger experiments and much more fun. So, and of course, it's part of my. I guess you could say it's a better Brexit than we've had otherwise. Yeah.
Yeah. So if I continue then, so my background is from Ericsson for many years. I was head of research strategies there, so I've been in research for very long. Not focusing specifically on data centers, but the latest developments and the interest for Nordics has made me come over to this sector or industry. So then I got involved in the northern part of Sweden with the data center industry. Facebook coming to Luleå was kind of the kickstart, I guess, for me. As well as there's an interest for edge. So all in all, it happened so that RISE wanted to start up a lab, and I joined in and to get it started. And that was 2016. We got the first things together, and we were 3 that moved in to where we are now. And I don't know. I think might be 26 today plus students. So quite a fast development and a huge lab with a lot of stuff to do, a lot of fun, wind tunnels, etc.
So that's a pretty sizable team, Tor. Now, the Research Institute of Sweden, what is the goal of that institution? How was it set up? And then what is the perceived or the recommended or the goals on the outcomes of the research up there?
Yeah, so RISE is the Research Institute of Sweden. It's a state-owned company spread all over Sweden. We are the northernmost outpost. The RISE as a whole is working on a lot of different fields, from material, cars, steel, digital systems, name it. And there is one unit somewhere that is working on it. So, and the goal for RISE is, of course, we're Swedish-owned, state-owned. So the mission is to help Swedish industry and the public sector, support the development of services and technologies and products, so help Sweden to grow. That is kind of the mission statement, and be a research and innovation partner, because we are not a consultancy company or the advanced aspects of taking the next step, the transformation, that is what's interesting. And of course, transformation of Sweden is going on high speed now. And the interesting thing is that the northernmost part of Sweden is where the biggest transformation is going on. This new startup is going to make a huge steel plant, making steel with zero CO2 emissions. And the other steel plant that already exists here will do the same. And the mining industry will go net zero, etc., etc. So it's a huge transformation, climate transformation and digital transformation going on in the northern part of Sweden, with all the data centers landing as well in the Nordics. And in the northern part of Sweden. That's very interesting. Yeah.
Now,
so we are here. Yeah.
Yeah. Are most of the projects sustainability focused or an efficiency focused there, or do you do things outside of those two areas?
It's mostly focused. You know, I turned 60 yesterday, as I told you before, and I have my first grandchild, and the second is on its way. So I would like to do my thing to help the next generation that is coming, that innocent. They have not been part of making this world like it is today. So they leave something better to them.
Yeah, it's a very admirable viewpoint. Now, I know that both of you have extensive background in data center research, and Jon, you have some very interesting views on PUE and efficiency. So can you share those views and your perspective on PUE?
Yes, I mean, it's PUE is it's a funny one because it can be misused quite heavily, and I think we've been having discussions a lot recently about PUEs in the sense that that there is a standard around it, and it's interesting how academics come along and they can kind of reinvent the PUE in a sense, you know, by doing certain things with it. But unfortunately, it's as a standard, it's well described in the standard. And I think whenever we talk about PUE, we should probably talk about ISO PUE, because then it makes more sense. It's annualized, it's recorded, it's measured at the granularity that is supposed to be measured at in terms of the standard. But it's not an efficiency measure. I think that's one thing that we've got to get right. The whole overall data center efficiency has to include the IT, and I think the PUE has been a marvelous instrument for focusing attention on the envelope. So it's all about power distribution, cooling, and of course the number of companies that have come out of the cooling technology space and the different ways you can cool data centers or remove the heat from data centers, and even to the point where you can start to reuse the heat, particularly with, you know, liquid cooling. And I think, you know, we have to be careful here, because I don't think air or liquid, whether you use gas or liquid, makes any difference in terms of the efficiency. What it does do is it raises temperature. So I think, you know, and when you start reusing the heats, there's a temptation to say, oh, my PUE can be altered slightly because I'm reusing the heat. But no, you can't. It's an ISO standard. Let's go back to the ISO standard. There is an ISO standard for reusing the heat, and so and that's the problem, is that now we have several metrics. In fact, I think we've got 9 on this stream of ISO standards that are 30134 series, and renewable energy factor as being one of them, energy reuse factor, carbon usage effectiveness, water usage effectiveness. They're all there, and we should refer to those standards. But it doesn't, all of those together, and I've seen academics now trying to put these metrics all together by weighting them and then coming up with an overall efficiency metric at the end. We always want to go to one single number, but it doesn't work. We can't do that, and I think that's where a lot of the research has been focused on that aspect. So energy efficiency in data centers is really what we want divided by what we have to pay for, because there's the engineering energy efficiency, and what we want are the digital services, and what we have to pay for is the electricity metered kilowatt hour. And so if we go down that path, then the question is how do we measure those digital services? And that's where it gets really interesting, because it's not just the hardware, it's not just the envelope of the data center, it's not just the IT, it's the software and then the applications that sit on that. They're all important as part of the energy efficient measure.
So what you're saying is that we're likely not going to get to just one metric for us to be able to say this is X or this is Y.
No, I don't think so.
And you'd mentioned also that there's optimizing for PUE has some counterproductive effects. Can you explain more about that?
Yes, that's a fun thing, yeah, in a sense. I mean, we were fortunate to have a data center as a playground, so we could actually orchestrate the workload, and from the orchestrating the workload, we had a very, very detailed monitoring system around that. So we were able to measure, fan usage, fan energy usage in the servers, all the way up to the cooling unit. So we were using a direct fresh air system in the north of Sweden. And what we found is that what we wanted to do is slow everything down. So slow down the speed at which the air is coming into the building, slow down the speed at which the air goes through the servers. And of course, as you slow down air, as it passes over the heat-bearing elements within the server, then things start to get a little hotter. But the interesting thing is if you build your controls around keeping those CPUs at a constant temperature all the time, then so there's no fluctuation in temperature from the CPU. It's the fans that are doing the fluctuations, not the CPUs. Then you get a higher delta T. So what we found is that there is a relationship between the delta T across the servers and the PUE. As you increase that delta T, the PUE drops. But in terms of optimizing to this degree, what we found is that when you start to run hotter with your IT equipment, they draw more power. And we've focused in on this in using the wind tunnels by putting these servers in a very, very controlled environment and looking at the pressure drop across the server, looking at the workload, the power draw of the server and the power consumed by the fans and the temperatures, both front and back. And what you can see is, obviously, as you draw more power in the IT, your PUE starts to drop because it's in the denominator. And because you're slowed down the fans, the cooling fans, you're using less energy in the cooling, so your PUE is dropping even further. But what you then look at is you say, well, here's the scenario where we didn't do that, and here's the scenario where we did do that, and you compare the power consumption, and in some instances, you find that you started to increase power, even though your PUE has dropped. So that's why you have to be really careful here, because it's not a metric that really, it's good at finding problems with your data center in terms of continuous monitoring of data center, but PUE as an overall metric and saying, look, we are the best, we are the most efficient is not, it does have some caveats to it that you have to be careful with.
Really, a really interesting method, the way that you've talked through the rationale behind PUE. Now, Tor, what is the right way then? If we don't have anything better than PUE right now, what is the better way to measure efficiency in a data center, Tor?
Yeah, looking at the holistic, that has been our starting point already from the beginning when Jon and I met, to look at the holistic view, try to optimize the whole data center, taking the IT, the workload, everything into account, and look at how we can decrease the energy used by the whole thing, and still getting those digital services out with the correct SLAs. That is the way to go. And so, of course, going back to what Jon said, that we want to get out divided by what we have to pay. And then, of course, what we have to pay has to be clean. And what we have to pay could also be the material we use and many other things. That's a new thing that we have started to get very interested in, to look at the whole, what we pay is not just renewable energy. It could be materials going into the data center, and where are the materials going then after operations, etc., etc. So that is, I think, the new track. We are going to do a lot of projects now.
Sure, a lot around the scope 3 emissions and those type of things.
Yes.
And then back to the measurement, I can imagine even being able to measure the impact at the software layer, Jon, has got to be a huge challenge ahead on the workload piece, and being able to measure that's got to be monumental.
That is, yeah. I mean, that's going to be a real challenge. And I think it's, I guess it's really interesting how things will develop, particularly as the next generation of server probably doesn't give you the same leverage on energy efficiency as the previous one, as previous generations, because the Moore's law is slowing down. We can't deny that fact. And of course, we need to. Now we're collecting so much more data from so many things that we're doing across all of the spectrum of where digitalization is infiltrating. That processing that data, etc., is going to be key. But it's really I'm not sure how you do this really, and I think it's really an open question to everybody out there. Really, how do you measure the energy efficiency of the software itself as well? Because the other angle to this is particularly when you look at sustainability, is that if that software is dematerializing society, then it's not just the fact that the software is efficient, but it's the fact that it's removing other instances of where we are generating unsustainable activity in what we do. So, and it's still an open question. I know the likes of Jesse have tried to talk about this through their Smart 2020 and then Smarter 2030 arguments about the digitalization of, so we get smart energy, smart health, smart everything. I don't know how smart education.
Yeah, but we need smart code as well. I think. The paradigm, software development paradigm for many years has been grab any code that is like a black box, use it if it's possible for you to very fast develop new code. So the code in itself has started to become very inefficient. So I think we will come back to the 80s when I started engineering. We were very much into code optimization to fit it into the small new CPUs that came out and DSPs that came at that time. We were code optimizing a lot to enable GSM, for example.
Yes,
but then, so this will come back. We need to get back to that.
I mean, the other angle of this, and it goes back to the energy efficiency piece, and I always like to make the analogy with the automotive vehicle, because a lot of people have, experience of this. When you go out and buy a car and you say, if you ask the guy who's selling you the car, how efficient is the car? He will say, well, it depends how fast you drive it. If you're pressing the pedal to the ground all the time, then you're not going to be that energy efficient. Now, data centers or operations, we talk about operations per second per watt. But that's really operations per kilowatt hour. So does it really matter? Some things are time dependent, other things are not time dependent. So you could be more energy efficient if some of those digital services do not require instantaneous response, but they could be run at the sweet spot, if you like, the sweet spot of the hardware and the software layer combined. And finding that sweet spot is a really interesting research challenge as well.
Oh, especially if you're sitting on a colo and you have to monetize all of that capex that you've already put into the building, and you have to make your money somewhere and your margin. So speaking of data centers, now you're both involved in the Boden data center project. in the north. Now, that's been up and running now 18 months. Has it been almost 2 years?
It's actually finished, unfortunately. The end of last year was the end of the project, but we still like to talk about its legacy. I think it did leave some really interesting. We produced a huge data set which is open access to anybody who wants to download it, and anybody who wants to check our official ISO PUE that we put out there. it's there for
officially the project now. So then what happens now with the data center that's sitting up there? What are you doing with that equipment and that building?
It is sold to a new company that do, I think they do video rendering.
Okay.
So it's probably a lot of Hollywood films going on there. I don't know. No. So it's the background rendering for the next whatever series.
Now, so
and
Tor,
it's done efficiently.
Of course. Now, Tor, I noticed recently you posted something on social media that had an Edge OCP rack with some nodes. So talk about the Edge project, what you're working on there.
Yeah, of course, this is kind of in the heart of my interest right now. It's an Ericsson interest. What is going on with 5G? Why is 5G great? I have seen when we started to look into 5G, 6G technologies in the future, and we starting to put together tables and see, looking at the different speeds and bit rates and number of devices connected, etc. There was one thing that kind of were sticking out, and that was the delay. So we are now, instead of being, when GSM was developed, the large part of the delay was in the mobile system, and the small part was in the internet. But now with 5G, 6G, the small part will be in the mobile network, and the big part will be in the internet. That makes it very interesting. It's an exponential change. And with the exponential change, there will be a lot of innovation. So edge on the net, and when I'm talking about edge, I talk about network edge, not the edge. There's some talk about it on the device. That's where you're going to do the compute. Right. And some talk about the edge when you connect to the mobile network. That's current edge, where the CDNs are. But I'm talking about the network edge when you put compute at the base station. And that will make a great change. Lot of new applications that we haven't seen before, because it's impossible to implement. It can't be implemented on the device because the device is battery and CPU limited. It can't be done in the cloud because it's a long delay. So it will happen in this network edge node. So we have start building a couple of those. We have done a couple of projects, and the one I posted was our latest open compute based, hardware-based edge node. 15 servers, inbuilt active cooling, a dry cooler on top, 10 kilowatt about the node in total, GPUs in all servers. So this will be a very powerful tool to place by a base station, 5G base station. So that is what we have done now in project with the university here. They have a 5G network. They are into radio. We are not into radio, but the university here is into radio together with Ericsson and the mobile operator Telia, and they put up they have soon a network of 5G nodes here, 5G innovation testbed. And there we are placing these edge nodes, and we're going to do a number of projects to look into applications that can really benefit from 5G delays and low delays and edge capacity at the base station.
You're working with the Luleå University.
Yes,
different than RISE.
Yes.
Different, and then also the Swedish government and Ericsson on this. Is that correct?
Yes, exactly.
Wow.
Yes.
Okay.
So it's a very, very interesting project. So we will continue. We will build some other nodes as well. We will play around to see where will this go, what could be the best way to do things, etc., etc. So this one, I would think that this edge capacity stuff will happen first in enterprise networks. So 5G now will be single access, single user kind of So that is there are versions of 5G that you can put in kind of into an enterprise scenario, like in a mine or on a steel plant, or and in those places, then if you put edge capacity there, you will be able to do completely new applications for that area, a smaller area. It's not the kind of a global scale for them yet, but that will be the starting point. Then, so this node that we designed is fit for that. It's you can place it in a printer room or some little cleaner place. You will not put. You need to do something else with the cabinet if you want to put it out in a mine, because that's really dirty. But
Sure,
but in a coffee room, in a printer room, close down in the mine, it would fit perfectly.
Now, as you look at these edge applications and all of these different places where you're going to be putting smaller, more micro data centers, is the way to should enterprises just be focusing more on heat reuse and how to capture that heat? Because measurement at those micro data centers, how should they be viewing heat reuse in their overall strategy? If I'm a typical enterprise out and I don't have access to the Nordics or central heating.
Yeah, of course, small nodes, 10 kilowatt, it's not producing much heat. So it could be, depending on how the other infrastructure looks like, it could be a very costly way of trying to do heat reuse there. That's for sure. So that's not a simple. It's not a simple answer to that question. Is not so simple. It's probably not some other situation when you are maybe in a city, when the city network of edge nodes start to build out. Then we will place them in different buildings, and then it might be much easier to do heat reuse of such small amount of heat. But there we have another project that I could introduce that we are doing, combining fuel cells and data centers, and using the fuel cell as a heat and power production unit, like a CHP plant. And that is, of course, John Summers' other project is deeply involved in that, and that's very interesting. And that could be seen as an edge for a city, and it's very fit for the rest of Europe. In the Nordics, maybe you need to use gas, but
so John, explain a little bit more about that.
Yes.
Yeah, I mean, it's an interesting project in the sense that I think with heat reuse from data centers, if you could look at the history of data centers, and it's interesting when I've sat on a table at one of these award ceremonies, which is to do with air conditioning engineers, and they always say, "Why do you guys hate the compressor so much?" And I said, "Well, it's just too energy inefficient. So plus the fact we can remove the heat by different ways. So we've been spending all this time getting rid of the compressor, and now with heat pumps, we're bringing them back in. Of course, data centers don't want to manage heat. It's not their prime focus. But unfortunately, we have a lot of it. So this particular project was based on the fact that I think using gas, and the fact that natural gas, maybe in the future we will merge electrolyzed hydrogen, green hydrogen, from overcapacity in the renewables into the mix, and you can use fuel cells. They're quiet. They also can be used as a combined heat and power source. They're on site and they're quiet, and so that you can put them into inner cities. Let's think about it. Where is the consumption of the digital service going to be? It's going to be in urban areas. That's where everybody is. So it makes a lot of sense to try and use fuel cell. And again, if you combine that with liquid cooling, which is what we're doing in this project. So first of all, we're primarily cooling the OCP gear. We're using OCP gear in this as well. We're cooling those servers using immersion. and then we're upgrading that heat through the fuel cells to a temperature where we are getting to the point where we can reject it to the supply line of the district heating network. So the challenge is for us in running this system is it's a great idea, but probably not the right geography to do it in. It's so damn cold. No, there's not much gas, and the district heating operates at a very high temperature. So we've really challenged ourselves there. Yeah, but it's something that can be used.
Yeah, but can it be done in Luleå? Then it can be done all over the place.
That's right. That's the motto. Yeah,
that's the motto. And I think that's a good place to wrap it up because all of the things that come out of northern Sweden are always fascinating. And so I encourage everyone out there to search on RISE, the Research Institute of Sweden on YouTube, and Jon Summers and Tor. They're doing some fantastic work. And I really, really appreciate the time, Tor and Jon, and really appreciate your involvement in Open Compute. You guys are fantastic collaborators and really the essence of what an open community is. So thank you both and appreciate your time.
Yeah, thank you for having us. Really, it was really fun.
Thanks for the support as well. Thank you.
Yes, yeah, thanks for the support. Yes.
Great. Okay. Well, I'll be back with my key takeaways from my conversation with Jon and Tor in just a minute. As I mentioned at the beginning of the session, how much I always learn from Tor and Jon, and today was no exception. They always get me thinking differently about a few areas. The first is that PUE is not an effective measurement moving forward. And we've heard this in the past, but the way that they phrase it is really, really drives home that point. And the way that if you optimize for PUE, in many cases, it can drive down the efficiency within the IT infrastructure. And how the true way that we should be looking at energy efficiency would be to take what we want and divide it by what we have to pay for. And how we as an industry are always trying to boil it down to one metric. And Jon saying that that is nearly impossible. We shouldn't be focusing just on one metric to then stack rank everyone accordingly. And then lastly was on the software efficiency and how do we measure the efficiency of the software code? Is it a dematerializing engine for our infrastructure? So my appreciation to Jon and Tor from RISE for all of their insight and their community partnership. I hope you enjoyed this week's episode and be looking for more conversations in the coming weeks. Thanks again for listening and cheers.